While the basics have hardly changed, modern scientific balloon capabilities and dependability have increased exponentially. Evidence is found well north of the Arctic Circle near Kiruna, Sweden, where the midnight Arctic sun brings the snowmelt of summer. And one of scientific ballooning's greatest challenges to date.
BLAST is perhaps one of the most sophisticated payloads we've ever flown.
In a collaboration between the Swedish Space Corporation and the Columbia Scientific Balloon Facility, here at the S-Range Launch Facility in extreme northern Sweden, an experiment called BLAST, or Balloon-Borne Large Aperture Sub-Millimeter Telescope, is being readied for flight. A week-long flight that will take BLAST to the opposite side of the globe, towards northwest Canada and Alaska. A flight that promises the BLAST science team more data collecting airtime than a flight from the continental U.S.
We're trying to learn about star formation.
BLAST is a very large and very sensitive 2-meter telescope designed to look back in time billions of years, to the point when the majority of stars and galaxies began to form in the early universe.
It's part of putting together the whole story of how do we go from the early universe, which was featureless, uniform, just the simplest gases, into the rich complexity we have today, and how did all those steps come together?
The fundamental concept of cosmology that allows scientists to peer into the past is the fact that light takes time to travel.
So if I look at the moon, I see the moon like it was about 1.5 seconds ago. So let's say something happens on the moon, 1.5 seconds later, we can see it. Or we look at the sun. We see the sun like it was 8 minutes ago. So an event happens on the sun, we don't see it for 8 minutes. Something happens in a distant galaxy, it's maybe 1 billion light years away. We don't see that event for 1 billion years. So when I go and look at a distant galaxy, I'm seeing it like it was 1 billion years ago. I have no idea what it looks like now, and I have no idea what it looked like 2 billion years ago. But I know what it looked like 1 billion years ago. Let's look at a galaxy that's farther away, farther back in time, nearer, more recent.